Today we're going to do a very interesting experiment, very basic in physics, but I've never seen it done before. What we've done here, we've placed a wire coil with about 800 turns of 0.5 millimeter wire on top of a 12 volt DC drive motor or a little shaft, and I've hooked up some slip rings. So what we can do is we can get DC power from this device, about 25 volts, 1.5 amps, coming through the red of the black wires into this coil while it's spinning in a fast rotary motion. And then we can measure, does the electromagnetic field made by the coil get stronger or weaker as it spins. Now there are various ways we could argue about this. Permanent magnets do nothing, but let's go ahead and do the experiment and see what happens. Okay, now we're going to test it. You see I've got 25 volts DC and 1.3 amps coming through these black and red wires into this coil, and we're getting repulsive that way and attractive that way. So now when I'm coming to this other power supply, I'm going to turn it on. It'll go really fast. We're going to see if the repulsion gets stronger or weaker while I hold the magnet over it. Here we go. So I'm holding the magnet here, repelling. It's going to go really fast now, so don't get close to it. And I don't feel any difference whatsoever. Let's do repulsion, turn it over. Now it's attracting the other way. Let's see how the attraction's affected. It's about 1,000 RPM. I don't feel any difference whatsoever. Okay, now we'll reverse the wires for DC power, so red and black are reversed. So it'll spin the same way, but the magnetic field will be different. So now I've got a repulsive field for blue rather than attractive. So let's spin it and see if the repulsion gets stronger as I spin it. There's really no difference. Now let's turn it over. We have an attractive field for red with the current reversed. Let's see if the attraction changes as I spin it. I can't feel any difference. So we've got a null result for this experiment almost no matter what we do. Today we're asking the fundamental question of if we take a wire coil electromagnet with DC power running through it, through these two leads, they're on a slip ring, and the current will run like that, and they make a magnetic field, DC, which they can either attract or repel a test magnet. Now at the same time, if we spin the disc really fast, like a couple thousand RPM using this little motor, will the magnetic field get weaker or stronger? Now there are various arguments can be made in both ways. Intuitively, if we imagine the current running around through the coil, we spin in the same direction, you might expect the field will get stronger. On the other hand, if it's current's running that way and we spin the other way, it might get weaker. However, we have the principle of relativity where, like in lens attraction, that doesn't happen. It's the relative motion between the wire coil and the magnet which causes the effect. And for permanent magnets, we don't see anything either. So in summary, today what I found is it seems to be the relative motion between the current electrons and the copper nuclei in the wire that creates the magnetic field. Spin in this large laboratory frame in an absolute frame of reference doesn't seem to affect anything. So I'm not sure how to formulate that mathematically, but it looks like a null result, and we don't seem to be able to get a spin-dependent magnetic field. I would certainly encourage other physicists or teachers to let their students do this and see what results they get. Thank you very much.